Hey, students, what is happening? How is your life in Corona Valley? I don't know about you, but I am so ready for this whole COVID thing to be over. Every time I get out of my car to go anywhere, to the store or anything, I always forget my mask. I got to go back to my car and get it. So I will be very happy when this stuff is gone, gone, gone. Okay, we're going to do a kind of a tough lesson today. I have total faith in you. I know you can do it. You can always come back to this recording and watch it again if you need help doing the problem set. Okay, before I get started, I want to remind you that the final draft of your mini paper is due this Saturday night, October 17, 1 minute before midnight. So you want to make sure and start at least by Saturday night at 11:30. Sorry, I just like to joke around. All right, let's get serious. I'm going to click this PowerPoint lesson and open it up. We are testing differences between means. We're going to calculate a certain value, and then we're going to look in an appendix and find another value, and we're going to compare those two. The null hypothesis in this situation is that there are no differences between means. That is designated by this notation. This backwards U with a leg on it is the Greek symbol mu, which I like to call mu because I have kitty cats. Yeah, okay, I'm weird. The population of the first group in a null hypothesis is the same as the population in the second group. An example of a null hypothesis: age has no effect on level of computer skill. So if you took a group of respondents and split them in two by age, you would be saying that those under 30 and those 30 and above would have identical levels of computer skill. The opposite of that is the research hypothesis, which says there is a difference between means. And in this case, this equal sign with a slash through it means that these two groups are not equal. An example of a research hypothesis is that age has an effect on computer skill, level of computer skill, which makes a lot more sense to me, and I'm sure to you also. Because most all of you were born with laptops in your lap. You've had computers all your lives. You're very, very good with them. But I'll give you an example of, age having an effect on level of computer skill. A long time ago, when my dear departed mother was still alive, I tried to teach her how to use a computer, and woo, boy, was that fun. She had never seen a computer before, so it was not easy for her. So I think that research hypothesis here just makes a lot more sense to us. If you reject the null hypothesis in any problem, then you automatically accept the research hypothesis that a true population exists. And we're going to do a whole lot of math to find these two t values. And then we're going to make a decision. We're either going to accept or reject that null hypothesis. So you're going to calculate a t value. Then you're going to go into the appendix and you're going to find a critical t value. In order to do this in the appendix, you need degrees of freedom, which we are also going to calculate. The appendix has a selection of levels of significance. When we get to it, you'll see that it has probably a half dozen different levels of significance. For these problems and for the problems next week, you will always use the 0.05 alpha level. Always. You will use the column that has the header of 0.05. The appendix is in Cougar courses this week. So when you start working the problems in the problem set, that's where you find the appendix. Be careful which 0.05 column you use, whether it's one tail or two tail. I will always tell you whether it's a one tail or a two tail test. Excuse me. Like I'm doing here. This example that I'm going to show you is a two-tailed test. All that means is that when you get to the appendix, you're going to look in a certain location for that 0.05 column. Okay. You are always going to start out with two columns of numbers, like I have here. This is x sub 1, that is the first group. This is x sub 2, that is the second group. Okay, the first thing you're going to do is to square each of these numbers and put that value to the right of it, in the column to the right of it. So what I've done is I have squared 5 and gotten 25. I squared 10 and gotten 100. If this is an actual problem, I'm going to square all of these numbers and put their values here. I'm going to square all of these numbers and put their values here. Okay, when I'm done with all of that, I'm going to add up the numbers in each column. So I'm going to come up with 4 sums. Okay? So let's pretend in this two-tailed test problem that we start out with a table with 35 Asian and 35 Latino respondents. The N for both groups would equal 35. Remember what the N is. It stands for the total number of values in each group. So the first thing I'm going to do is put that over here on the right-hand side. N equals 35 for both of these groups. If I added up the original column of numbers for the Asian respondents, I would get 217. If I squared each of those values and added that column, I would get 1,563, which I have over here. Okay, just like it says down here, keep track of all your numbers on the right-hand side of your sheet or whatever you're working on. So I have the two values here. I'm going to do the same for the hypothetical column of Latino respondents. I'm going to add all those values and come up with 189. I'm going to square all those values and come up with 1195. So I put all 4 of those numbers here, and the next thing I need to do is to find the mean for each column or each sample. Okay? Now I have the numbers I need to do that. For the first group, remember, to calculate the mean, you are summing the values and then dividing by the number of values. So I've added up the numbers for the first group. It's 217. The number of values in that group is 35. If I divide 217 by 35, I will get 6.2. I have the sum of the original values for Latino respondents is 189. If I divide that by 35, I'll get 5.4. Well, this is why you keep all these numbers over here, so you can constantly go back and refer to them to do the next step in the part of the whole problem. Okay? Next, I have to find the variance for each of these columns or each of these samples. The formula for the variance is exactly like the one for standard deviation. Okay, you did that 2 weeks ago. It was the sum of the squared values divided by the n minus the mean squared. The only difference in standard deviation is that you had a square root sign over this. When you calculate variance, there is no square root sign, but the formula is identical. sum of the squared values divided by n, and that number you subtract the mean squared from. And guess what? I have all of these numbers over here, right? The sum of the squared values for the first group is 1563. The n is always going to be 35. And the mean squared, well, let's find that over here. I don't have that. But I have the mean, which is 6.2. So if I just square that or multiply it by itself, I'll get 38.44. That's how I came up with this number. Okay? And then I just do this division, come up with 44.66 minus 38.44, and I get the variance of 6.22, and I put that over here. For the second group of Asian respondents, I have the sum of the squared values in this column. It's 1195 divided by the n, which is always 35, minus the mean squared. Again, I don't have the mean squared over here, but I have the mean. So I'm just going to multiply 5.4 by itself and get 2916, and that's how I got this number. Okay, so if I do this division, I'll get 34.14, subtract 29.16 from that, and I'll get a variance of 4.98. And I'm going to take that number and put it over here. Okay, again, it's just a matter of looking at the formula, replacing the values, and finding what you're looking for. You know, keep going down, down, doing the math, and then finding the value that you're looking for. Woo! Excuse me. Okay, you ready to get blown away? Oh my God, look at that. This is terribly intimidating looking, but you know what? If you take a closer look at it, it really isn't. We have to find the standard error. This over here is the symbol for the standard error. And this gigantic formula is how we need to calculate it. But look at it. All it is a whole bunch of n's. Okay? And we know that n equals 35. So we just need to replace all these n's with 35s. Look at all those 35s. Oh my God. The only thing that's different is the variance. In this part of the problem, you are multiplying the n times the variance. So the variance of the first group that we just calculated is 6.22. So the n times that. The variance of the second group we just calculated is 4.98. And then we just have a whole bunch of 35s. So if we calculate 35 times 6.22, we're going to get 217.7. If we calculate or multiply 35 times 4.98, we're going to get 174.3. And then 35 plus 35 minus 2 is just 70 minus 2, and that's 68. And then over here, it's just 35 plus 35 is 70. 35 times 35 is 1225. And then we just go down to the next step. If we add these two numbers, we get 392 divided by 68, and we just pull this whole thing down, 70 divided by 1225. So if we divide 392 divided by 68, we get 5.7647. And 70 divided by 1225 is 0.0571. And if we multiply these two numbers together, then we will get the standard error, which comes out after all of this stuff, all this work we had to do, we get this tiny little number, 0.3294. And I'm going to put that over here because I'm going to need that number for the next step, which is so much easier, thank the maker. In order to get the calculated t-value, I just need to do this simple fraction. I need the first mean divided minus the second mean divided by the standard error. Okay? So I have both the means over here. The first mean 6.2 minus the second mean 5.4, and then that number I divide by 0.3294. So let's do that. 6.2 minus 5.4 equals 0.8. That's what I get here. Now, if I divide 0.8 by 0.3294, then I'm going to get, oh my God, this gigantic number. You know, this is what calculators do. They give you a result with a billion numbers over here. Now, all I've done to get 2.43 is rounded up the 2. You know, by taking the 8 and rounding up the 2 to a 3, and that's how I get 2.43. Okay? That is my calculated t-value. I'm going to put that here because I need that too. You know, all the way from the very beginning, every time I calculate anything, I'm putting it over here. Okay? So now I need to find the degrees of freedom, which is very simple. We already did it in one of the other steps. N of the first group plus n of the second group minus 2. So 35 plus 35 minus 2. 70 minus 2 is 68. So that's our degrees of freedom. We know what our calculated t-value is. We need to go into the appendix to find the critical t-value. Now, when I show you the appendix, there is going to be no degrees of freedom of 68. So I need to drop down to the next lowest degrees of freedom, which is 60, and find whatever the value is in the 0.05 level of significance column. And that's how I come up with a critical T of 2.00. Now let's look at it. Here's the appendix that you're going to open up anytime you do one of these problems. And remember what I said. You may have a one-tail problem or you may have a two-tail problem. In this case, we have a two-tailed problem, so we're going to look for 0.05 here. Look up here in one tail. It's over here, and you're going to use this column. But for a two-tailed problem, here is 0.05, and we're going to use this column. We're going to go all the way down. Remember, we couldn't find 68, so we just drop back down to the next lowest degree of freedom value, which is 60, and go all the way over here, and this is how we find 2.00. Actually, it's 2.000 in the appendix, but I'm just going to take one of those zeros off because I am the mighty professor and I can do anything. And that critical t value is 2.00. Now we have all this information. Are we going to accept or reject the null hypothesis? Well, in this problem, we're going to reject it. And the reason why is because the calculated t of 2.43 is greater than the critical t of 2.00. If the calculated t is greater than the critical t, you reject the null hypothesis. Okay? Isn't that awesome? Aren't you just so glad you learned all of that? And what you're going to do is the problem set for differences between means, which is located in Cougar Courses, and I will be with you on the first problem. That'll be another video in this week in Cougar Courses. So come back and refer to this video to remember how to do these problems. Okay? Yeah, it's hard. Yeah, it's new. But you know what? You can do it. The math really all comes down to addition, subtraction, multiplying, and dividing. Okay? I know you can do this. All right. I'll see you in the problem set. See you later.